of vegetarian cheese to Indians in various flavors. From grandmothers to children, cheese is loved by all. Cheese which we relish every day is processed in the most modern, fully automated and state-of-the-art Amul food factories.
World's most loved food product, cheese, has a fascinating processing journey. Let's take a tour of one such factory to know how the cheese is made.
From the first drink in the morning to the last meal, since 1946, Amul has been serving people of India and even outside India. Amul, the taste of India, is the largest producer of vegetarian cheese in the world.
It tantalizes the taste buds by providing a variety of high-quality vegetarian nutritive cheese like cheddar, mozzarella, Gouda, Emmental in various forms like cheese blocks, cubes, slices, cheese tin, cheese spread and many more in many flavors.
Cheese, which is a rich source of protein, calcium and phosphorus, is used in making various food items such as pizza, burger, salads and many Indian traditional foods like cheese paratha and cheese dosa.
Cheese is probably the only food item in the world which has 2,000 different varieties and is consumed across the world.
20 million metric tons of cheese is produced worldwide each year, and people who love cheese are called turophiles.
Let's explore how it is made in a modern Amul factory.
High quality cheese is only possible when the milk which is used to make it is also high quality standard. This is one of those many dairy farms under the vast network of the famous Amul model of milk producers cooperative societies. Amul ensures only the best milk is used to make the cheese.
And this assurance of best quality milk comes from its 3.6 million milk producers owners spread across thousands of villages in India.
Every day, milk producers walk to the nearby milk collection centers with 21 million liters of milk.
Amul facilitates village milk societies with chilling units and quality testing equipment to maintain high milk quality at village level itself.
Every day, lakhs of liters of milk from hundreds of societies reach cheese plants through special tankers.
And this milk is transported under low temperature. This definitely can be called as the Amul's Milky Way. Milk reaches the processing plant in a couple of hours, twice a day, round the year, uninterrupted and processed in its various factories located across India.
At the milk reception bay, a trained factory supervisor who welcomes the sealed milk trucks. Here, these milk containers are connected to pipes through which milk reaches inside the pre-treatment area.
Once truck is at the bay, before unloading, sample of raw milk from each tanker is taken for lab testing so that milk quality can be tested and recorded for various parameters such as fat, solid not fat also known as SNF, bacterial load, etc.
Computerized milk testing is done so quickly that within a few minutes results are made available. Once quality is approved, milk moves from the collection bay to the raw milk storage silos within no time for further processing in a fully automatic plant.
Automatic processing plant is monitored by computers. Just a couple of people manage almost 30 lakh liters of milk processing at this section. This is incredible.
I agree with you. This is really incredible. Next, milk moves from raw milk storage to the processing section. It goes through chiller and the automatic bacteria clarifier machines to filter out bacteria from the milk. A separator removes extra fat from the milk before the milk heads to the pasteurization stage.
That's cool. Until now I thought cheese is fattening, but now I know that Amul makes fat-controlled cheese.
Next, in the automatic pasteurization process section, milk is heated at 72 degrees centigrade for 15 seconds to make it almost zero bacteria milk. It's like a shock treatment. Now milk is stored for a few hours in huge silos at chilling temperature. It's like waiting in the queue to become cheese. The next journey for this milk is the cheese plant.
To keep cheese processing plant bacteria-free, plant staff has to go through air chambers before entering the plant. Here, air blows away all dust particles and foreign material. Literally blows away dust particles.
In the cheese plant too, computer handles most of the process automation. It decides what to do if there is any problem in the production line. Barring a few steps like culture and rennet mixing, rest all are automated.
The very first step in cheese making process is mixing culture into the milk at a certain temperature. Like humans, cheese too has to have a culture.
Oh, that's an interesting observation. A specific quantity of culture is added to the milk. Culture acidifies the milk at certain temperature, like we make curd at home. Culture also enhances the characteristic flavor in the cheese. Now this cultured mixed milk is mixed thoroughly in these vats by blades which are fitted inside. This process goes on for 30 to 45 minutes.
Let's know more about the culture. A cheese culture is a group of specific bacteria put together for making a specific cheese. Cultures rapidly raise the acidity of the milk by consuming the lactose, also known as milk sugar, and convert it into lactic acid. Starter cultures also aid in development and preservation of the flavor and texture of the cheese.
Next 30-minute, vegetable sauce rennet is mixed into it and left for some time to coagulate at 30 to 32 degrees centigrade. First, it is dissolved into the water and then added.
Amul makes 100% vegetarian cheese because it uses only vegetable source rennet, which is a one-of-a-kind enzyme obtained through biotechnological process.
Unlike other imported cheese available in the market, Amul cheese is 100% vegetarian cheese.
Wow, that's wonderful. I didn't know this. I'm a pure vegetarian and now I can also have cheese.
Once milk is coagulated like homemade curd due to enzymatic action, an expert checks its suitability for the next stage. Oh, he really cuts the curd.
That's the way it should be tested. Satisfied, he gives a green signal to start the next processing step.
Curdy milk is then artistically and lyrically cut into small pieces in vats. This is magical and fascinating to watch, and it is like an opera. Thoroughly cut curd is continuously stirred and cooked by adding hot water to the jacket of the vats for 40 to 60 minutes.
Next, solid curd is separated from watery residue, which is known as whey. Whey is drained out for other process and solid portion is taken away to make cheese.
This segregated curd is further milled and cut in a cheese master chamber.
Next, over the well-mingled solid curd, a moving salt sprayer completes salting process. Salt helps to improve the flavor of the cheese. Also, it reduces acidity and unwanted bacterial growth.
Now it's time to have some pressure, real pressure. Solid curd material is pressed in vertical compression towers, which make any remaining whey to seep out and allow solid curd to acquire block shape.
These pressed large blocks of 20 kilograms are placed in food-grade plastic bags and a journey starts. A metal detector en route to labeling and weighing station checks the blocks for purity. A block's journey does not get completed without taking a holy dip in hot water for a few seconds. This makes the block further hygienic and bacteria-free.
Once bathed, blocks reach the weighing and labeling station. They are given an identity. After all, identity is very important for everyone's life. They are labeled with batch, date and weight details. Blocks are now kept in plastic crates and properly stacked on the pallets. From here, the cheese block's journey start for curing, which we can call as storage for 4 to 6 months at 8 to 10 degrees centigrade in huge temperature-controlled storehouse.
Cold storage where curing happens is almost 44 feet high. Manual as well as fully automatic forklifts and storage systems are used to stack and remove these pallets.
Cheese curing is also called alternatively as cheese maturation. It's an important process in cheese making. Curing induces distinct flavor of the cheese and through the modification of ripening agents determines the features such as taste, texture of many different variety of cheeses. Oldest commercially available cheese in the world was cured for 40 years.
Wow, it almost sounds like double life imprisonment.
Let's come back to cheese. Once cheese blocks are matured, they start a new journey and are taken to the processing area. Here cheese is transformed into various products like cheese cubes, cheese slices, cheese spreads, tin cheese, etc.
Pure cheese is now called cheddar cheese. Do you know why it is called cheddar cheese?
Let me Google it.
I'll tell you. It originates from Cheddar village in England and so it is named as cheddar cheese. Now this cheddar cheese batch goes through the taste buds of an expert tester who green signals to move the batch to the next stage of processing. Probably the grader is the most critical person in the whole process.
Probably healthy too, as he eats lots of cheese every day while testing.
With a blast. As rock explodes and the raw materials of steel are tossed from the earth. The rock is taconite, and the prize inside is crude iron ore. We get at it by grinding the rock to powder and separating the ore with powerful magnets. Then we form and heat the ore into marble-sized pellets that will later be converted to iron. From bituminous coal, we create coke to fuel the iron-making furnaces. We crush the coal, seal it in airtight ovens, bake for 12 to 16 hours, and remove it from the oven as solid carbon fuel. The fuel and pellets come together in the blast furnace, where we add just enough limestone to remove impurities. From below, a continuous blast of superheated air combusts the coal, intensifying the heat and changing raw materials into molten iron. Sometimes more than 9,000 tons of it a day in our largest blast furnace, where it reaches a temperature of 2,700 degrees Fahrenheit. At regular intervals, we tap this blistering brew into giant submarine ladles that ride on rails to the basic oxygen chamber, where iron will be turned into steel. In this fast-paced sequence, up to 250 tons of steel can be made to order in less than 45 minutes. We begin the steel-making process by dumping recycled steel scrap into the basic oxygen furnace and adding hot iron. Sparks steal the show when high-purity oxygen is blown into the mix at supersonic speeds and molten iron becomes molten steel. Now we're ready to create the custom blends that make steel the most widely used metal on the planet. In fact, we produce over 1,500 different chemistries to meet customer demand for cutting-edge, value-added steel. Look for another show of sparks as we tap molten steel from the Bop vessel into a ladle. Then, for most of our steels, it's on to the vacuum degasser, where they are made highly formable. The focus then shifts to forming and finishing, which determine even more of the steel's characteristics. The first step in this sequence is to position the ladle above a massive tundish or funnel that feeds a continuous caster containing molds that shape the steel. The molten steel, now at 3,000 degrees Fahrenheit, is channeled from ladle to tundish to caster, where it cools to a red-hot solid. The shape of the mold determines the shape of the semi-finished products that come out of the caster. And since most U.S. steel plants make sheet products, most of our casters output slabs, typically 8 to 9 inches thick and 3 to 5 feet wide. As they exit the caster, slabs are cut into sections up to 40 feet long and stacked to await further processing. Then it's on to the hot strip mill. This is where we begin transforming steel slab into steel sheet. Slabs are reheated to 2,400 degrees Fahrenheit, and descaled before running through a series of roughing stands that make them thinner and longer. Then they cycle through finishing stands where they are rolled even thinner. Finally, they are cooled and rolled into coils that may be thousands of feet long but only fractions of an inch thick. A far cry from the chunky rectangle that came out of the caster. And the entire process is untouched by human hands, controlled instead by operators using state-of-the-art automated equipment in pulpits that overlook the action. Next, we move to the pickle line, where coils move through an acid bath that cleans the surface. Some of the emerging coils are shipped directly to customers as hot band. Others are destined for applications that require special finishing, beginning with cold rolling to make them even thinner. At that point, coils may be shipped or go on to one or more additional finishing processes. Coating to make the steel resistant to corrosion. Tinning to further reduce the gauge and add the tin coat we commonly see on canned goods. Annealing to make steel that is easier to bend and form. And tempering that uses special rollers to add hardness and create surface textures and other special finishes. In fact, many of our products leave the finishing facilities as the industry's newest superstars. Lighter, stronger, highly engineered, formable steels that were unheard of just a few short years ago. No wonder the story of steelmaking stays so fresh, with innovations that guarantee something new to see in each showing, with product placements in our homes and high-rises, on our highways and in every other part of our daily lives, and with a cast of thousands who continue to improve and perfect every step of the steel-making process, from shaped pellet to shipped coil and beyond.